Hello everyone, welcome to November 2018 paper 1 for grade 10 pure mathematics. We are going to look at question 2 in this short video. Please like and subscribe so that you have notifications of all future videos. Let's start with solve for x 2.1.1. First thing that I notice is that x is common on the left hand side, so I'm going to take x out, which is good because I want to solve for x. So I like to write in blue. I'm going to write P plus Q is equal to A. Now I want to get rid of this P plus Q, so I'm going to divide both sides by P plus Q, divide by P plus Q, and therefore these two cancel out. On the left hand side I have X, and it's equal to A over P plus Q on the right hand side. That's your final answer. Question number 2 gives me a trinomial equals 0. We want to solve for x. Now I'm going to have two brackets, and I'm going to have factors of 2 is going to be 2x and 1x. Let's try and factorize this quickly. So I know I've got 2x and 1x, and then the factors of this 2 is either going to be 2x and, sorry, not x's, 2 times 1, or it's going to be 1 times 2. Those are my options. So if I look at them separately, let's say 2 times 1, when I multiply this, I get 2x. When I multiply this, I get 2x. So that added up gives me 4x. That's not what I want, okay? So now I'm going to try the other one, and I'm going to say 2x and x, 1 and 2x. So when I do this, I get 4x. And when I do this, I get 1x. And if I add them up, 4 plus 1 gives me 5x, and that's exactly what I want. But I want minus 5x. So now minus x and minus 4x gives me minus 5x. Minus and minus gives me plus. So I'm happy with that. So my answer here is going to be that's minus and that's minus. 2x minus 1 and x minus 2x equals 0. Now, we have not yet solved. I don't know why I keep writing x's where they don't belong. We have not yet solved for x. So at this point, I'm going to write two brackets, and I'm going to say 2x minus 1 equals 0, or x minus 2 equals 0. 2x minus 1 equals 0, so 2x equals 1, and x equals 1 over 2 on the right hand side. So first option, on the right hand side I'm going to say x equals 2, and that's my two options, my two solutions to this question. All right, in this one we have a half to the power of 3x plus 1 is equal to 32. Because my exponents are variables, I know I want to make my bases prime numbers and then solve the exponents. So let's work on the left hand side. The first thing I want to do is change this a half to a 2. So a half means 2 to the power of negative 1. And the rest I'm going to keep the same, 3x plus 1. No changes there. On the right hand side, I'm going to change 32 to 2. And that is 2 to the power of 5. So now I have a same base. What I'm going to do here is I'm going to multiply my exponents. So this is going to be 2 to the power of negative 3x negative 1 is equal to 2 to the power of 5. Now I'm going to take my exponents. Because my bases are the same, they fall away. So that and that is going to fall away. It doesn't cancel out. I just eliminate it. And I'm going to say minus 3x minus 1 is equal to 5. So now I'm going to take the 1 over, and I'm going to say minus 3x is equal to 6. Now I'm going to divide both sides by minus 3. So this means that x is equal to negative 2. And that is my final answer. Okay, now we have a inequality with two inequality signs. We want to solve for m. That's what question number 1 says. So to get this, I am going to look at my middle section, and I'm going to say plus 8, plus 8, plus 8 on all three sides. Now, when it comes to inequalities, what you need to remember is the sign changes when you add or when you multiply or divide by a negative. If you're adding and subtracting, the sign doesn't change. If you multiply and divide by a negative, then the sign will change. Otherwise, the sign stays the same. So this means that on the far left, I have 8 minus 11, which is going to give me minus 3. And that's less than and equal to 3m, because this cancels out. And that is less than 4 plus 8, which is 12. Okay, once I've done that, I am going to divide by 3 to get m alone. Divide by 3, divide by 3. So this means this becomes negative 1 is less than or equal to m, because those two cancel out, which is less than 4. And this is the answer for question 2.2.1, the end. Okay, question 2.2.2 is saying write down the number of integers that satisfy the inequality. So how many integers satisfy? If I use a number line, I can draw a number line like this, and I start at negative 1, which means this is 0, 1, 2, 3, and 4. If I drew this, this is not the question. The question is not asking me to draw it, but I'm going to. Less than an equal, greater than and equal to means that I'm going to have a colored in circle, and this one is going to be an open circle because there's no equal sign. This is what it looks like. So which integers or how many integers fall into this? It's going to be 1, 2, 3, 4, 5. This one does not fall in because it's an open circle. So my answer to question 2 is going to be 5 integers. Okay. All right. Question 2.3 is simultaneous equation. Solve for x and solve for y. Now what you're going to do is you want to isolate one or the other. You can choose which one. Okay, you choose which one you want to isolate. I am going to choose to isolate y over here because it's already 1y. So what I can do is I am going to isolate it by saying, okay, let's name this. This is going to be equation A. This one is going to be equation B. Okay, now I'm going to take 3 over. So I'm going to say 2x minus 3 is equal to negative y. Then I am going to divide everything by minus 1. So I'm going to say y is equal to negative 2x plus 3. And I'm going to label this one equation C. So I got 3 different equations, right? Now I'm going to substitute equation C into equation A. That means that equation A says 5x plus 4y equals 12. And I am going to say 5x plus 4 times, instead of saying y, I'm going to say this, minus 2x plus 3. And that is equal to 12. Now I'm going to multiply that out. So 5x plus, not plus, minus, sorry, minus 8x plus 12 is equal to 12. Let's take our 12s. What am I doing? Hold on.